So we're going to spend a little time today getting up and running with Calico Host Micro-segmentation protection on AWS. We were originally scheduled to do this on Azure, but we're going to do this on AWS today. The good thing is, and the good news is that it's pretty much the same implementation no matter where you get up and running with Calico Host Micro-segmentation, whether that be on-prem or in a particular cloud environment. There'll be a couple of different nuances, and I'll call them out as we go through this, and we'll follow up with another event later on that is tailored specifically to Azure. So you'll have like some automation around the host microsegmentation agent installation will be done for you in Azure. Let me just come down here to the slides. My name is Jonathan Sabo. I'm a senior solutions architect at Tigera. Today, what we're going to be doing is going over Calico Host Microsegmentation protection. We're going to go over some of the deployment considerations that you want to take into account when you start to decide how you're going to go about deploying host microsegmentation. We're going to actually stand up and deploy Calico Host Microsegmentation control plane. We're going to be using AWS EKS for the control plane. If we were happen to do this on Azure, we could do this with a self-hosted Kubernetes cluster or Azure AKS. Today we're going to be doing AWS, and we're going to be using EKS. We're not going to be doing anything with Kubernetes specifically. We're going to be focused on enforcing policy using the same Kubernetes network policy model, but we're going to be doing it for VMs inside of the cloud. Then we're going to, after we've got the control plane up, we're going to deploy Calico HMS protection to a Ubuntu VM, and we're going to go through just a very simple policy use case that we'll get to do that together. It'll be kind of a little bit interactive. All of the installation files and the documentation are captured in our GitHub at github.com/Tigera-solutions, and you can see I just pasted the link into the chat. So thank you for your time. I appreciate it. Let's just go over a little bit about Calico Host Microsegmentation protection, and then we'll get to the demo. Looks like we got some questions. Let me see if I can get to Q&A. Doesn't look like Q&A is going to work out for me. I'm having trouble seeing the questions in Q&A, so feel free to ask them in the chat, and I'll try to respond to those, or just feel free to unmute yourself and to speak. One of the challenges that people find when they start managing the security for workloads inside of Kubernetes or inside of the cloud is that the cloud host environments, they're a moving target. The compute that you stand up, or developers or teams of developers are launching and using, they're dynamic, and the IP addresses change. And to further complicate that, there's usually these environments can span multiple accounts, like multiple virtual private clouds inside of an account. And the cloud, sometimes you'll find that they'll have like overlapping IP addresses. And so if an organization didn't plan out the IP address allocation across accounts or VPCs, you can find that things overlap. So will you be covering an update with Calico with EKS or AKS? We're going to be using EKS today. So one of the things that you'll see is when the source and the destination IP addresses change over time, the historic flow logs that you capture, they'll no longer be traceable. You'll have, as nodes are coming and going, the IP addresses are going to change over time. And so it really creates this need for some sort of workload identity that's not tied to an IP address. And one of the other things that we've heard from people, from some of our customers, is that some some of the solutions that were built for static VM-based environments. They just can't handle the dynamic environment and the dynamic nature of the cloud. We at certain scales, policy changes can take up to 2 to 3 hours to be enforced. And when launching the programmatic compute power of a cloud is just at your developer's fingertips, that's just kind of not really realistic to be waiting 2 hours or so to be able to securely use compute inside of your account. So the situation that the teams managing this find themselves in is that they need a way to perform micro-segmentation of these cloud-based hosts. They might have tens or hundreds or thousands of VMs across these different accounts, different VPCs, and in certain solutions that they're trying to use, we've been hearing that the policy engine can take sometimes up to hours to propagate rule changes. But at the same time, you just can't circumvent these security requirements that these policies are meant to enforce. It's very important to have the segmentation between the VMs to minimize the blast radius of a breach and to be able to maintain compliance with security criteria. So the solution to this is to enable the automated protection of the cloud hosts, the VMs, and we can implement the security controls as Kubernetes network policies using Calico network policy. After having done so, we will be able to use the evidence reports, the change history for each control, and we'll be able to audit that and be able to prove compliance to our security policies. We'll be able to define the security policies using the same metadata, the Kubernetes metadata, the labels, and we'll be able to model out segmentation patterns by applying policy to the VMs themselves. I guess they're gonna mow my lawn, so forgive the background noise. Looks like these guys showed up here a little early. One of the things that it lets you do is this will let you eliminate the need to update network security policies for each instance. Calico network policy will be applied dynamically and enforce policy across your fleets of VM instances using automatically and dynamically using Calico network policy. Calico network policy is built for these dynamic workloads. If you're not familiar with Calico, it's very similar to a firewall, except that instead of using IP addresses, we're using Kubernetes label selectors to be able to target specific sets of nodes and to apply policy. As new workloads come and go, new VMs come up and go, only the appropriate labels have to be applied to these workloads to ensure that the same policy will be applied. And this supports cloud instances, static VMs, or even bare metal nodes inside of your on-prem environments. You can see over on the right an example security control that we see from time to time. We'll see that organizations will want to segment their release process. They want to have policies that separate dev from QA, QA from prod, dev from prod. And you can see here that we've got like a sample Calico policy that is implementing that segmentation. Calico Host Micro-segmentation, it allows you to have a bit of a defense in depth posture in capabilities. So we're not saying don't use your NSGs, don't use your security groups, don't use your virtual appliances that you might be using. We're giving you another layer of defense in depth to be able to apply policy and secure the traffic coming and going from these dynamic workloads. What's special about Calico Host Micro-segmentation is that it scales to very high numbers of endpoints. It's Kubernetes scale, so orders of magnitudes more than what you might typically see if you were deploying something with like VMs or bare metal nodes. The traffic rules, there we have the ability to apply policy at a couple of different places. You can see over here on the right, we can apply policy inside of the container at the border of a pod, and we can also apply policy on the physical interfaces of the bare metal nodes or the VMs themselves. And we're going to be focused on this particular place right here, this host, the host-based services, this particular policy enforcement point. That's where we're going to be applying policy today using host micro-segmentation. One of the beautiful things about Calico host micro-segmentation is that it's hybrid and multi-cloud. So we're going to be focused on EKS today, but this solution works across all the public clouds using the public, the managed Kubernetes offering AKS, EKS, GKE, or even self-hosted Kubernetes distributions in any of these clouds or in your on-prem data center. So no matter where you happen to be deploying Calico or Calico Enterprise, you have the same capabilities across these different environments. Let me just take a look at some of these, the comments here. So you mentioned Calico and Ubuntu. So one of the questions from the chat, when you mentioned Calico and a Ubuntu VM, did you mean Ubuntu VM that has a Kubernetes cluster, or a VM that is part of a node of an EKS cluster, or an independent VM that needs to communicate with services hosted in an EKS cluster? Calico host endpoint protection or host micro-segmentation protection can actually enforce policy in every one of those scenarios. Today, we're going to be using EKS as our control plane, and we're going to launch a VM outside of the Kubernetes cluster, and we're going to register it with the Kubernetes cluster. And so the VM itself has absolutely nothing to do with Kubernetes. It's going to be a pure VM based workload, and we'll see that in just a moment. So just in summary, Calico host micro-segmentation protection, it allows you to implement your existing security controls as Calico policies. It implements policy from a single control plane. Today, we're going to be using Amazon EKS as the control plane, and it will automatically generate evidence reports as proof of compliance to your network policies that you define as Calico policies. Just lastly, before we get started with the demo and the walkthrough, I just want to bring your attention to Calico Enterprise, our trials. We have, you can sign up at tigera.io/trial. You can go through some of the different use cases that are made available as part of a walkthrough for Calico Enterprise. Calico Enterprise builds on the free set of use cases that is available with Project Calico. Some enterprise use cases like policy auto creation. We can observe all of the communication inside of your Kubernetes clusters and automatically create a least privilege network policy for you. We have the ability to preview the impact of a particular policy, and we have the ability to stage it in kind of a permissive mode before you enforce your policy. We also give you some connectivity policy troubleshooting tools to make it easy to track down policy issues as you continue to segment workloads inside of your Kubernetes cluster or outside of your Kubernetes cluster. It's all the same. We also have some advanced capabilities around egress access controls. Some of the more popular ones that we see in the clouds inside of Azure, inside of AWS, being able to restrict outbound access to things like RDS, things that whose IP addresses change over time and are not under your own control. AWS manages those for you, or Azure may manage those for you. And so what we will allow you to do is to define policy using the DNS names and maintain the IP addresses that those resolve for you, so you make sure that your network policies are always correct. We also have some corporate security controls, compliance reporting, and threat detection. All right. So we're going to come over here. Today, we're going to be doing AWS Host Micro-segmentation, and we're going to go over a little bit of the agenda of the demo in just a second. Let me take a look at some of these, the questions in the chat. Does Calico come with built-in policy sets for HIPAA, high trust PCI, CIS? And once we deploy EKS with Calico enabled, how does one keep Calico updated to the latest, greatest version? Is it a manual update? We have some example policies in Calico Enterprise. I believe we do have some policies that are address the controls required by the different security criteria families. If you're interested in that, check with us, sign up for the trial, let us know. We'll be happy to work with you on that. The second part of the question, once we deploy EKS with Calico enabled, how does one keep Calico updated to the latest, greatest version? Calico has, depending upon how you deploy it, there's an open source version of Calico, there's a manifest deployment, and then there's also an operator-based deployment. The operator, and there's also a Helm-based deployment as well. So depending upon how you deploy Calico or Calico Enterprise, you want to refer to our release notes. You want to take the release notes into consideration. You want to also follow along with the upgrade steps. They're all documented in our docs at docs.projectcalico.io or .org and docs.tigera.io. All right, so let's get started. So some of the considerations up front that you'll want to take into consideration here are the system requirements for the nodes that you're going to be deploying the host microsegmentation agent on. Let's just take a look at those. So first of all, we need to be able to have a Linux kernel that is relatively new, not too extraordinarily new. We've got support for 3.10 or later, and you can see some of the required dependencies down here. We'll look at these in just a second. You can see we go back to like Ubuntu 16.04, so a couple of revisions of LTS. And then the Red Hat 7 and Debian 8. You can see there's also some networking requirements that you want to make sure that the nodes in between inside of EKS or the Kubernetes cluster that you're using will have connectivity to be able to talk to each other. And then just you want to make sure the version of the operating system, the important part is that you have these kernel dependencies satisfied. If you're starting off with one of the Linux distributions above, that won't be an issue. We're going to be using Ubuntu 18.04 for our host microsegmentation nodes today. Another consideration is the installation method that you want to use to install the Calico Host Micro-segmentation. You have a couple different options. So if you come here to docs.projectcalico.org and you come down here to non-cluster host, you can see the installation instructions, and that's where we're at right here. And you can see that you have the ability to do a container install. So if you want to install Docker on your VMs and you want to be able to run Calico node as a container on your VM, you can do that. We also have a package manager installation that automates some of the steps with the binary installation. And then we have a binary install without the package manager. And that's what we're going to do today. You'll see I've included a install script that will automate the installation for us as part of this demo. But by all means, you have to consider whether or not you want to have a container runtime on your VMs or not, and whether or not you want to use our packages or build your own, or just script the install. Another consideration is the data store type. We support a couple of different, there's two choices that you can have. You could use an external etcd That's just kind of like the older way of doing things. Most people should be using the Kubernetes data store. It simplifies some of the configuration. You can see that we don't have to, there's a couple of different, there's less variables here, and we can make use of the Kubernetes API to restrict access and control via RBAC what these endpoints or the agents are allowed to do as they connect in and get registered. So that's what we're going to do today. We're going to use the Kubernetes data store for our configuration. We're going to use the Kubernetes. We all commonly refer to this as KDD. So if you see people, you hear people say KDD, that's what they're talking about, is the Kubernetes data store. So in order to get going, what we need to do is we need to deploy the host micro-segmentation protection control plane. And so the first step of that really is we need to create a place to deploy it in. And so we're going to launch a VPC, and we're going to use a CloudFormation stack that I've prepared. And if you come down here, you can take a look at this diagram. What it does is it just carves out a VPC with IPv4 network slider and some subnets for each individual availability zone, optionally with private subnets. We're going to be installing into the public subnets. And then we're going to be launching an Amazon EKS stack that's going to bring up an Amazon EKS cluster that is going to be the central control plane environment that we're going to use to register our Calico Host Micro-segmentation agents into. And they're all going to connect into EKS, and we'll be able to leverage that control plane to apply policy to VMs using Calico network policy. So we got off to a bit of a late start, so let's get going here. I've already took the liberty of deploying a couple of these stacks for us, so we're not going to have to wait around, but just so you can see that there's no smoke and mirrors here. I'm going to go ahead and just apply these CloudFormation templates. And you can see that CloudFormation, it's idempotent. It's realizing, hey, the stacks as defined in code inside of this GitHub repo are already deployed, and there are no changes required to be able to get going. So the next part is this. We're going to update our local kube config. So we can talk to our cluster, and then we are going to just check out and see if we have any nodes defined here. Let's go wide. All right, so we have a VPC launched, we have a EKS cluster launched, and we've updated our credentials locally so we can talk to the cluster, and we can see that there's currently no node resources showing up here inside of the cluster. And the reason for that is we need to be able to, we have to update this AWS Auth CM. And what this config map is going to do is it's going to be used to allow RBAC access to the IAM users and roles. And what this will do is allow the nodes to join the cluster. So we're going to just update this config map with our account ID. We'll just take a look at it real quick. Come back over here. It's just AWS Auth. So you can see we're allowing, we've just got a variable in here for the account ID, and we're going to update that with my account ID. Just going to dynamically grab that. We're going to update the config map, and then we're going to apply it. And what we're going to see here in just a moment is for every node in the cluster, you can see we have some now, and they're reporting not ready. And in just a minute, you're going to see them become ready. And then we'll be able to start going here. The next step after this is we'll install Calico. All right, looks like we've got our nodes are up and ready now. All right. So now we have a fully functioning EKS cluster. Let's take a look and see what's running inside of the cluster. You see, this is just the bare nodes. And it looks like the AWS CLI nodes are still coming up. So let's give those a second. All right, they're ready to go. All right, the next thing we want to do is we want to install Calico. So I'm going to be using a just the template-based install. Let's take a look and see what's running now. You can see that we've got a Calico node coming up for every one of the physical nodes, every one of our EKS cluster members. Let's give those a second to start. All right, they're up and running. And well, we can see them here. And so the next part that we need to do is we need to assign Calico HMS RBAC user the Calico node cluster role. So let's go ahead and do that. Let's take a look at that real quick. What we're doing is we're assigning a user Calico HMS the cluster role Calico node, and that will allow the Calico Host Micro-segmentation agents to be able to pull policy and apply that to the bare metal VMs, or the VMs inside of the cloud. So the next part that we need to do is we need to launch a VM outside of the cluster. We're going to create a Ubuntu node outside of the EKS cluster that's not running Docker, or it's not running it's just a VM outside of the cluster. So I'm going to go ahead and do that. You can see I've already taken the liberty to do that, and there is no changes. So let's keep going. Let's go ahead and let's take a look and see what EC2 instances we've got going. It looks like we've got a Calico demo HMS node, and this is the public IP address for that particular VM. I'm just going to go ahead and assign that to a variable. And then let me echo that out to make sure that it's the right one. So these match, right? All right, good. Okay. And so what we're going to do is I'm going to SSH out to that node, and I'm going to clone this Git repo to it. And then we are going to update the account ID inside of this install script, and then we're going to SSH out to the node, and then we're going to install the HMS agent. So let's do that together now. And so we're going through things kind of a little bit fast here. But the good thing is that you guys have access to this Git repo, and you'll be able to reproduce this in your own environments. A little disclaimer, we are standing up compute inside of AWS, and that does cost money. So if you happen to go through this on your own time inside of your environment, just please be aware that you will be incurring the cost for the EKS cluster and the VM. So just be aware of that, and then you probably want to clean up after the fact. There are some steps at the end of the tutorial that show you how to do that. All right, so let's cd into this directory. All right, let's take a look at this. So we're picking a particular version of Calico up here. So there's just a couple of different variables up here that you might change. There are new versions of Calico out, and there's probably been a couple of different releases since I've updated this. But I want to show a couple of different things that we're doing inside of this install script. We are installing a container runtime. We're using Docker, and we're going to install the dependencies for host micro-segmentation. And you want to make sure that you install IPset and Linux contract. We're going to need those in order to get those dependencies that we saw earlier inside of that requirements doc that we have. And then the next part of the installation script is really just some niceties for us. We're installing, we're going to pull down the containers, and we're going to copy out the binaries from them, and then we're going to install them into user local bin, and we're also going to pull down Calico Cuddle. Now, if you were managing fleets of VMs, you might choose not to install the Calico Cuddle CLI on the VMs. You could choose to do that in like a central location, like a jump host or something along those lines, and then you could configure the Calico Cuddle CLI using the kubeconfig to be able to talk to your EKS cluster, and to be able to apply, edit, to be able to do like all the CRUD things, all the creations, updates, removals of network policy. So we chose to use the KDD installation method. And so what that allows us to do is to kind of simplify the configuration. All we need to have is a valid kube config, and the Calico Host Micro-segmentation agent that's installed on the VMs will be able to use that to talk to Kubernetes, to be able to talk to EKS, and to be able to pull down the policy, and to be able to dynamically update policy as you centrally manage the security for your fleets of VMs via that central control plane, in this case EKS. The agents themselves will be watching for changes and will be applying those dynamically across all the VMs. And so we're gonna just kind of template out that kube config. So let me just hop out of here. Let's come down here. So let's do the installation. All right. Let's let this go. So let's come back up here, take a look at the chat. It looks like I want to come back to the Calico HIPAA and PCI CIS, these security criteria families. I'm curious if there's specific controls that you're looking to implement inside of those. There's some of the controls can be addressed via network policy, but there's also other functionality that Calico and Calico Enterprise provides that would address other controls, like specifically HIPAA. We recently added the ability to do node-to-node encryption for Kubernetes nodes. So that would satisfy one of the criteria for HIPAA specifically that says that all PHI has to be encrypted in transit, and then you would have to ensure the at-rest portion using another manner, but it just kind of gets you a little bit closer to compliance. So just keep in mind, it's Calico Enterprise has capabilities beyond network policy that will get you further towards your compliance requirements. All right. It looks like we're officially installed. Let me just, what we're going to do now is we're going to run the FELIX, Calico FELIX service using Ubuntu's systemd system. So we go ahead and just get this going. All right, and you can see the Calico FELIX agent is now actively running. And you can see, as if you run general control, you can follow along and watch the output from the systemd service that's running here. All right, so let's take a look and see all of our host endpoints that we have currently. It doesn't look like we have any set up at the moment. So let's just make a couple of changes here to the configurations that we have here. All right, so this is a host endpoint definition. And you can take a look here, you can see that it's got a name and it has some labels. The labels that we have here are the labels that we're going to be able to use to target these particular VMs, and we're going to be able to apply policy via these labels. So if we had some host endpoints, some VMs running in in US East 1 and then US East 2, and we had a policy that applied to just US East 1 or just US East 2, what it would let us slice and dice up these VMs to be able to control who can talk to one another. Maybe we would have another label that is like release type. It could be dev, and we could have another and another VM would have release type QA or release type prod, and we could create a policy that targets the dev VMs and say, hey, these dev VMs are not allowed to talk to the QA VMs or to the prod VMs, and vice versa. There's a couple of different things that we want to make sure line up. We want to make sure that the node and the expected IPs line up. You can see that the IP here is the same and the node name is the same. Let me just take a look here at these, the chat. Is there a central portal repo to control HMS from multiple VMs? Would we reference the labels in case deployment YAMLs reference these labels? Yes. So the Kubernetes cluster, the EKS cluster, is the central control plane for all of the VMs that you choose to register to it. So if you have a central account, a central AWS account where you have built out like a shared services VPC, and you might be using either the connecting, there's a couple of different ways that you can connect VPCs to one another using one of the transit gateway is probably the latest, greatest way to go about doing that. And what it would allow you to do is to have routable connectivity across from VPCs defined in different accounts and in different regions back to the central VPC where you could potentially have installed Calico, with EKS like we're doing right now, and then setting up Calico like we're doing right now, and then registering the VMs in all of the different AWS accounts and all the different VPCs back to this central place, and then centrally managing the security for those workloads running across accounts and different VPCs, and doing so in a low latency, highly scalable, label-based way using the same Calico policies that you would be applying in other clouds, potentially on-prem. All right, let's keep going. So we have, let's apply our host endpoint. So we've updated it with our IP address. We've applied the host endpoint. And so now when we look at the host endpoint, we're querying EKS at this point. We're using Calico Cuddle. We're authenticating to EKS using our kubeconfig. And we're asking EKS, hey, what are the host endpoints that you have defined for yourselves? And it is returning us this answer, and it's showing us the host endpoint definition. So you can see that this host endpoint, this VM, is now registered into our control plane. All right, so now let's apply a policy to this particular VM. So let me just export the AWS default region. I always get that wrong. Is it a default AWS region or AWS default region? Let's grab the IP address. Okay, but here, let me just grab it real quick for us. Give me 1 second here. And what we're going to do, I'm going to make some space over here. Let me just make it a little bit. All right, and let me recenter this terminal. Let me look at this 1 second here. All right. And right now, I'm trying to ping this IP address, and I'll paste this IP in here inside of inside of the chat too. And you guys that are following along from your laptops at home, you can try to ping this IP address too. And you can see currently, I'm from my location, I'm not able to ping this particular this VM that is launched inside of AWS, and you can see that it's not allowing us to do so. So now let's take a look at some network policies. So what we've done thus far is we've created a VPC inside of AWS. We launched EKS inside of that VPC. We installed Calico. We have also launched a VM outside of EKS. We've got just a VM just running Ubuntu. We've installed Calico Host Micro-segmentation agent onto that VM. We've registered it with EKS. So now we've got a Ubuntu VM registered with EKS. Now imagine we did that 500 other times. We had 500 VMs all registered in with a set of labels that would allow us to apply policy. So that's where we're at right now. So now let's take a look. Let's look and see. We don't have any network policies applied. So now let's apply some. Let's take a look at these. I'm going to apply these first, and then we'll look at them together. All right. The first thing is let's take a look at the global network policy. So what this policy says, we'll look at this together, is we're selecting all of the VMs that have the environment type AWS and the platform type VM, and we're going to allow inbound access for ICMP. We're going to log the ICMP request, and we are going to then allow it for all sources that are attendee equal present. Okay. And we're also going to allow inbound on 80 and 443, but I don't have anything listening on those ports. So we're just going to be using ICMP. So any attendee that's currently present is going to be able to send inbound ICMP packets to it. Let's take a look at the other part of that puzzle. So attendee global network set. All right. And so the attendee present, so this is a Calico global network set. What this does is it allows us to define sets of CIDRs or DNS names and apply a label to them. And then we can use that label inside of the policy. So you can see anytime that our control plane sees inbound, well, actually, anytime that the individual VMs see inbound traffic, they're gonna see the CIDR, and it's going to have this label applied to it, and then we're using that label to restrict which sources are allowed to send inbound traffic to these VMs. So this global network policy is applied to all of the VMs that have the environment type AWS, and the platform is equal to VM, and we're allowing inbound for ICMP from the source attendee equals present. And what's decoupling this is nice for a couple of different reasons. What it allows us to do is to apply our policy and have that kind of remain static in our control plane, and then only update our global network set, which can be done programmatically or manually in this case. So I'm going to just go to my browser, and I'm going to type in what is my IP. And I can see that I have an IP address of a 10D global network set. And I'm going to change this to be my IP address. And I'm going to reapply that network set real quick. And now what I should start to see is that I should be able to ping that VM. So you can see almost instantaneously, we have the ability to attendee. Yeah, so if you drop your source IP inside of the chat, I can add you to the network set. Hold on 1 second. If I can figure out how to use them. See if cut and paste works for me once more. Nope, I'll just type it in. 173.174.85.116/32. All right. And I can just come in and apply that again. And you should now be able to also ping the IP address of our bare metal VM. Yeah. So and one of the you could see how quickly that policy change was propagated, and it happens in milliseconds. And one of the things that we hear from customers is that there's other solutions that people have attempted to use. I don't know, Illumio is one, Tetration. There's a number of ones that we've had customers tell us that either it takes a very long time for policies to be applied, or at certain scale, it just doesn't work. So let's just go ahead and finish out the lab here. You can see that we can query the EKS control plane via the Calico CUDL commands, and we're getting back the live global network set and the live policy that's applied. So we're centrally managing policy when we're enforcing network security controls across VMs outside of hosted outside of the cluster. One of the questions in the chat is, in the spec nets, can we also make lists of FQDNs? And if yes, would this require a DNS proxy? So DNS policy is one of the features of Calico Enterprise. And what I would suggest, if you're interested so yes, we can have FQDNs inside of our policies. That's a Calico Enterprise specific feature. You could get up and running with that and try that out in a few minutes today with our Calico Enterprise Accelerator, and we'll mouse or page over to that in just a moment. So that's kind of the end of the demo today. All of I'll bring draw your attention down here to the references. We have some docs on Calico Host Micro-segmentation. We also have, I'd like to point out this video, everything you need to know about Kubernetes network in AWS. We also did videos for Azure and GCP. So check those out. We also have videos for Ingress and some other Kubernetes constructs. They're really short videos. They're really well done, and I constantly refer back to them when I'm confused on like how are packets moving across the network using this particular CNI combination. As I was saying, we have a Calico Enterprise trial. It's our Calico Enterprise Accelerator. If you can sign up in a few seconds, and you can try out some of the functionality that was coming up in the questions in the chat, the ability to define FQDNs and policies and to apply policy. Just take one last question. Are there any gotchas while using service mesh with Calico, example, Calico Linkerd? I don't think so. They operate independently, specifically Linkerd. We do have an integration with Istio that if you wanted to use would give you another enforcement point that would allow you to do the cryptographic identity enforcement and the ability to have policies that filter for HTTP methods and paths. We leverage Istio for some of our layer 7 policy, and you can do that all with Calico policy all on its own. So you get a unified policy model with the addition of those enforcement points should you be choosing to use service mesh. Just another one of the things that we see people, we hear from customers, you do incur some latency for when you use service mesh. So if you're able to accomplish achieving the security control that using Calico policy itself, you can benefit from the low latency, high scalability implementation that comes with Calico Enterprise. All right, so that's it for today. Sorry for the mix up on the times. Appreciate everybody hanging out to the end. Check out the events calendar for any future events. Thank you very much for your time. I'm going to stop the session. I think that's going to kick everybody off of Zoom. Unfortunately, I'm not the Zoom master, but thank you very much for your time. Have a great rest of your day.